So I'm sure you probably know how to find the derivative of something using the power rule. With the power rule though, that requires that you have a function where you have your variable as the base and a constant power. But what if that's switched? What if you have a constant base and your power is where your variable is? That's going to be a little bit different. Well, recently in one of my weekly live streams that I do every Monday night at 5 o'clock Pacific, I talked about finding the derivative of a function that involved a 2 to the x power, a constant base raised up to a variable power. That's not the entire function that we took the derivative of. There was a little bit more to it, and it also involved the product rule. So I thought that would be an interesting example to talk a little bit more about and make its own video about. So if either product rule or exponential functions where you have a base other than e and your variable in the power are things that you want to have a little bit better understanding about, get a little more practice with, be sure to stick around to the end of the video because I think this one's going to help you. These are both covered on my free Calculus 1 study guide and my complete Calculus 1 package. The links to both of those are down in the description if you want to check them out. But without further ado, let's jump into the example and show you what I'm talking about. We're going to find the derivative of 2 to the x times, all in parentheses, x to the 7th plus 2x minus 16. So again, with product rule, first thing you need to do is just figure out what are the two pieces that are being multiplied together to give you this overall function. Well, since we can see this 2 to the x is being multiplied by all the stuff within the parentheses here, we could basically just call the 2 to the x one thing. Everything within the parentheses here are other things. So we'll say this is f and this is g. Then again, we need to find f prime and g prime. So the derivative of 2 to the x, and this is another formula on my Calculus 1 study guide. Link is down in the description if you want to check that out. But the derivative, if you're taking any constant raised up to the x power, the derivative of this is always just going to be ln of a times a to the x. So, you know, a kind of very specific example of a constant raised up to the x that we see a lot is the derivative of e to the x. Well, the derivative of e to the x is just e to the x. Right? It's a unique function where it is its own derivative. But that actually aligns with this formula here, because think about if we were to kind of use this formula instead, the derivative of e to the x would be ln of e times e to the x. Well, ln of e, the natural log of e, is just 1. So this is just 1 times e to the x, which is just e to the x. So this formula still works even if that constant is e. We just get a very, unique case where we don't have this additional coefficient constant that changes the value of the function. But either way, that formula can be used to find the derivative of that function, where basically a could be any constant. As long as a is a constant and there's no variables in it, that's going to work. So basically the derivative of 2 to the x is just going to be natural log of 2 times 2 to the x. Then we need to find the derivative of this other piece here. Well, the derivative of this piece here, we can do just using the power rule. So we'll take our power, bring it down in front, giving us 7, leave our x as x, and then minus 1 from the power, so 7x to the 6th. The derivative of a constant times your variable x is just going to be that constant, so the x will basically just fall off. And then the derivative of a constant is 0, so we're going to get plus 0, so that's not really going to do anything. Then just like we always do with these product rule problems, then we can kind of multiply across. So the original of 1 times the derivative of the other, the original of 1 times the derivative of the other, and then add those two things up. So you will get f, so 2 to the x, so y prime equals 2 to the x times, and now this is something I really want to point out here. Whenever your f or g or f prime or g prime is the sum of a bunch of different things. So in this case, we have this term plus this term minus this term. Here we have this term plus this term. Whenever you have terms being added and subtracted together that make up your f or your g prime or whatever, make sure you always put parentheses around the entire thing. So let's go ahead and make sure that we're putting these parentheses around all that and around all that. Because if we don't do that, this 2 to the x is not going to distribute like it's supposed to. So now our 2 to the x is going to be multiplied by all this. We're going to get 7x to the 6th plus 2, all in parentheses, right? So now if we were to think about distributing that, it would need to multiply to both of these terms. If you forget the parentheses, you might forget to distribute it, and then this 2 to the x will only be multiplied by this first term, and you'll end up with the wrong thing, because that's not the way it should work. Okay, so we multiplied g prime times f, then we want to add whatever we get from multiplying f prime times g. So we'll get natural log of 2 times 2 to the x times all this in parentheses. All right, and okay, so before we go on to the next step here, if you guys are getting value out of this video, please do me a huge favor. Go ahead and hit that like button down below. So I know you're getting value out of this and, you know, learning something from it and enjoying this topic. Anyway, so the next step at this point really, the only thing really to do at this point, and this kind of depends on where you're going with the problem, right? So like in this case, we're just being asked to find the derivative. If this was a part of a bigger problem where we had to find this derivative of this function and then do something with it, it might tell us what form we want to get this to. And what I mean by that is it going to be easier for us to factor stuff out or distribute everything throughout the parentheses? Because those are obviously opposite processes, right? So we could like distribute 2 to the x into the parentheses here, distribute the natural log of 2 times 2 to the x into these parentheses, and expand everything out. Or we could do the opposite and look for common pieces between this thing here, that is the product of these two things, and this thing here, which is the product of natural log of 2, 2 to the x, and what's in the parentheses. So we have a product of 3 things here, a product of 2 things here. Look for commonalities and factor them out. If we're just trying to get our answer in simplest form, probably that second option is going to be what we would want to go with. We want to factor stuff out. So we can see that both of these terms here have 2 to the x in common, right? We have a 2 to the x right here and a 2 to the x right here. So what we can do is we can factor out 2 to the x from this. So if we factor out 2 to the x from this first term, we're just going to be left with what's in the parentheses here. And if we factor out 2 to the x from here, we're going to be left with natural log of 2 times all the stuff in this parentheses. Right, so this 2 to the x is now being kind of distributed to all the stuff within here. So this would probably be, you know, the fully factored out version, as simplified as we could get it. I would probably just leave it here. Like I said, though, depending on context, you may want to have done the opposite and distribute these 2 to the x's into the parentheses. And that really just depends on what's going to be easier next. In this case, finding the derivative is all we had to do. This is as far as we're going to take it. There's really nothing else to do here. So that'll be the answer for that problem. Well, I hope you found that video helpful and you're feeling better about the product rule and also taking the derivative of exponential functions with a base other than e, like 2 in this case. If you did find this video helpful, do me a favor and hit that like button down below. It's a huge help to my channel so I can keep making more videos like this and we can keep crushing it all term long in calculus. Anyway, if you want to keep learning about derivatives or product rule or anything else about calculus, go ahead and click on one of those videos over there and let's keep on learning. Thanks and see you next time.